So this section is going to talk about the inner planets, and the inner four planets are rocky, they're small, they're like Earth. So they're called the terrestrial planets because terrestrial means Earth, and the four inner planets are rocky, like the Earth. So that's where the name terrestrial planets came from. So the first one we are going to look at is Mercury. So if you had to summarize Mercury, it's the closest to the sun. Here's how I would summarize Mercury. It's heavily cratered. It's got a lot of craters. Let me see if I can find a better picture about that. Okay. So it's heavily cratered. It has very, very high daytime temperatures. It does not have a moon, and it basically has no atmosphere. And because it has no atmosphere, it has no greenhouse effect. So let me explain that a little bit. When you have an atmosphere and there's not really like a plastic bubble that holds the atmosphere in, what holds the atmosphere onto a planet is the gravity. And so Mercury is not very big, so it doesn't have much enough gravity to hold an atmosphere there, especially given the heat of the sun that's there. So, because it has no atmosphere, it gets extremely hot during the day. And so, I mean, it can get heated up, and we'll see how that's different for different planets. So, with Mercury, is there any evidence that there was tectonic activity on Mercury in the past? The answer to that would be yes. There are cliffs, and there's one here called a scarp. And scarps are basically leftover parts of when Mercury was hotter, and so it was kind of a little bit larger, but then it cooled, and as it cooled, it went through a shrinking process, and it basically cracked as it kind of collapsed downwards a little bit. So these are called scarps, and they're just like little broken off cliffs. So Mercury's surface looks a lot like the moon in general. I mean, I think it looks a lot like the moon, just with rocks and craters and plains around it. So the next planet that we're going to look at is Venus, and isn't it pretty? So pretty. This is called Earth's twin sometimes, and mostly just because they're about the same size. They're both rocky planets, terrestrial, but they're also right next to each other in the order. This is planet number 2 or planet number 3. So Venus, if you had to summarize it, you would say it has a very thick CO2 layer. And because of that very thick CO2 layer, it actually traps a lot of the sun's radiation in it, and it bounces all around like a car heating up during the day is like the greenhouse effect. So the light stays in there and bounces around and makes it very, very hot. Because it has so much CO2. The higher level of CO2 that you have in an atmosphere, the more the greenhouse effect is going to take place, where the radiation won't be able to escape from the sun. Venus, so it has this thick CO2, it's got a strong greenhouse effect, there are volcanoes and lava flow, and there's no moon on Venus. Interestingly, you could also say that Venus has retrograde rotation, which basically means that all the other planets are spinning counterclockwise. So the way the clock spins, they're all spinning the other way, except for Venus. Venus is doing its own thing out there, and it is spinning clockwise as it goes around. So that's kind of cool. So here on Earth, the sun rises in the east and sets in the west. Well, it's opposite there. It rises in the west and sets in the east. So I wanted to explain the atmosphere of the CO2 because you could have questions about that. So the atmosphere of Venus is not just CO2, but it's also heavily nitrogen. So those are the two main gases. There's also some water in there, but the main two gases are CO2 and nitrogen. Venus because it's covered in a high concentration of CO2, the CO2 keeps the sunlight in. So this is called the greenhouse effect. And basically, that's going to be a raging debate. I mean, about our own planet as well. It has been for most of my lifetime that as we are getting a little more CO2, and it's just a small amount, but still, there's more, that our atmosphere is actually getting hotter. And those are all true. But then the debate is, how much is that affecting us here on the earth? What the good could be, what the bad could be, the ramifications, because on Earth we really do have kind of the perfect amount of CO2 in our atmosphere. So, but I will talk about that in a minute. But the amount that Venus has makes it so their planet is 464 degrees Celsius. That is so hot. That's actually 867 degrees Fahrenheit. Very hot. Um, is there evidence of tectonics in the past on Venus? Yes, there were likely volcanoes in the past. There could still be active volcanoes. I know it seems like we should have sensors all over this thing and know exactly what's there. We don't. We don't. There's a lot of discovery to still happen. So, get on it, kids. You guys go and figure it out. Okay. So the next one is the Earth. And if you were to summarize the Earth, you could say it has light, it does have light. It has life. It also has moderate temperature. So we don't get too hot, we don't get too cold. We're kind of just perfect. And we have water here as solid, liquid, and gas. That's huge for life. And then we also have a moon. So the reason that we have the ability to have water as a solid, liquid, and gas is because we are kind of the perfect distance from the sun. And then additionally, our orbit, even though there's times that we're a little closer and a little further away, our orbit is still pretty circular around the sun. So we don't have times that we're extremely close to the sun and extremely far away. So we're able to keep the solid, liquid, and gas water, which is great for us. So our atmosphere does have a really perfect balance of gases, but especially CO2 in it. So the greenhouse effect doesn't, it's just like the right amount. It's the right amount to insulate us, but it doesn't get boiling hot like on Venus. And so that debate will forever rage on about rising CO2 levels and what we should do about it. And I know that's going to continue through your lifetime for sure. So it's a constant conversation, and that's what people are talking about, sometimes in a very informed way, sometimes in non-informed ways. So the next one is Mars. So Mars, if you were to summarize that one, you could say, I wish I had a better picture of it. There, we'll go to this one. This is Mars. So Mars is small and it's red. And the red comes from iron in the soil. It has 4 old volcanoes. Then there's also a very deep canyon that it has. There is evidence that there was water in the past here. There may be some water deep on it still. Again, we don't know. Then there's 2 moons. 2 moons. That would be cool, huh? They have Phobos and Deimos are the 2 moons. And they don't have much of an atmosphere, so it doesn't have much of a greenhouse effect. So here's an interesting fact about the Earth and Mars. So the Earth has a smaller track orbit around the sun, and Mars has to go a bigger track or orbit around the sun. So every 2 years we kind of lap Mars, which isn't fair because they have a larger track, but whatever, we still lap them every 2 years. But as we're about to lap them for just a little bit, it looks like Mars is actually going backwards. Mars is not going backwards, it's an optical illusion, but that is called retrograde motion, when Mars appears to be going backwards once every 2 years, but it's really not. So on Mars, is there evidence of tectonic activity? The answer is yes. it has a large uplifted plateau, and it does have extinct volcanoes. All right, that's it for this section, and we will move on to the outer planets.